Well, good morning. Um, Today, I'm going to start looking at there's a there's a book that I uh, I recently discovered on Manning. It's called Five Lines of Code, and I wanted to discuss it. And I found it had a really clever approach to teaching refactoring techniques. Um, so I kind of wanted to do sort of a combination book review, but also just kind of walk through the refactoring that it does in some of the chapters and some of the ideas it talks about. Of course, if somebody has something else they want to discuss, feel free to bring it up and we'll be happy to talk about it. But for now, let's look at this. He talks about how there are basically three um, three areas of a your software development career, or what what you need to work with. Basically, you've got to develop your skills, you've got to work within a culture, and you've got to use various tools. And refactoring is sort of the intersection of all of those. You need the skills to do it, you need a culture that supports it, and you need tools to facilitate it. And that's pretty good insight. And so effectively, he says that the reasons that you want to refactor is you make your code faster, smaller, more general and reusable, or easier to read or maintain, or some combination of those. And he kind of takes the approach that there are rules to follow, and and if you follow these rules, then they will to implement these rules, you'll need to implement, you'll notice certain code smells. The rules will point out certain code smells, which will then uh, encourage you to use certain refactoring techniques. So, and then he talks about your software life cycle. And his idea of the software life cycle is that, you'll learn how to refactor. You've got to, basically, he says, first you're going to explore some problem. And you're going to specify a solution to that problem. You'll implement the specification, and then you'll test against that, and then you'll refactor it. And then, of course, that's what he's talking about in this book, and you'll deliver that solution. The users will like or not, whatever you're discussing, and then you'll go and further explore. Solutions, and then specify, implement, and then basically you're in this loop of how you get things done. So what he has done here is he's put together a simple little puzzle game, and he's written it in TypeScript, and you can get the source code from the link in the book. And he says basically, ideally, the way we're going to develop our skill set is you're going to follow the rules, the name of the rule, the description of the rule, and then master the code smells, and then we'll master those refactoring. So and so he sort of gives a quick overview of what refactoring looks like. And then, see, I don't think, does this, yeah, so this doesn't, this is more or less, how do you make code better? And, readability, maintainability, and he gives examples of each of these and how you can refactor this. Of course, his idea of refactoring is to use the Boy Scouts rule: always leave a place better than you found it. And that's really what we're aiming to learn here. So now we start diving into the code. Let me show you real quick here. So this is pretty much the tool, the program that he has. It's just a little web page, and you go and you solve this little puzzle by moving your red character, which is or red block, which is you, and you have to move it to the bottom right of the screen. And so you can go through the green areas, which are flux, or the white areas, which are air. Gray is walls, and brown is rocks. So if you remove the support from a rock, it falls. And blue is another kind of wall. And if you hit the gold is a lock or a key. So if you hit the key, then it will open the lock. And then you can make it to the bottom right of the screen. So that's kind of what we're talking about. Here is the code for the application that we're discussing, and it's TypeScript. And I'll be candid, I'm not really familiar with TypeScript. I'm a Java developer, so I don't know how the programming language works. But the application is simple enough, and the instructions are clear enough that I'm able to do the work that I need to solve the problem. Okay, so let's go back to the book here. Look at the first set of rules that he is going to introduce us to is using functions to break up long functions. So basically we'll use the extract method approach. And his goal is that no function should be longer than 5 lines. It's fairly arbitrary, but that's the rule that he wants to follow. Why 5 lines? He says, well, it forces you to make sure that your function's only going to do one thing. It says that the specific limit is less important than having a limit. It works to set the limit to whatever is required to implement a pass through your fundamental data structures. Since our data structures in this are pretty small, then 5 lines is plenty. So, and then he talks about, for instance, you've got this this function here. This is one. Your lines are lines without that have code on them and that aren't the function name. So this has 5 lines of code. 1, 2, 3, 4, 5. Pretty cool. And so he gives a little introduction to some of the TypeScript syntax for those of us who are unfamiliar, which is kind of nice. So like you don't have integers, any numeric value is a number. And he says that he prefers to use let instead of var because var has funky scoping rules. So the first thing we're going to do is the 5 lines function. Actually, you know what? I'm going to tell you the first thing I'm going to do. He's got the keys A, W, D, and S. I'm a Vim guy, so I'm going to change these characters to be H, J, K, and L. So H is left, down is J, up is K, and right is L. So I'll save that, and then I'll just do a Control-Shift-B to build. So it goes and recompiles it. And then I can go and look and see what I've changed in my code here with Git. And I can say, okay, I'm going to check that in. Oh dear, what is all this? It's like I need to create I'll just check everything in. So this is changing key move to Vim key. There we go. check it in and go right ahead. I don't want to see all that stuff anyway. And so real quick, we can go and test this, make sure that it works for H, J, K, and L. Done, and I'm happy. It's a small thing, but it works for me. Okay, so he says that we have a function named draw that is really long, and so he says, well, let's break it up. And the cool thing in here is that he's got the before and the after of the code, how to make what the code should look like. So basically, he's suggesting we break this up into two different functions based on the comments that are there. So if we look for the draw function right here, you can see that it's got a comment here, draw map, which implies that this is probably drawing a map, and draw player, which implies that this is probably drawing a player. So let's use our refactoring tools. We'll highlight this to Control-Shift-R. So we will extract this to a function in the global scope, and we'll call this draw map. And once we do that, the refactoring function goes and creates the parameter for me. So I don't need this anymore. I do that here as well. Refactor, extract to a function in the global scope, and we'll call this draw player. Why not? And then we can delete that. And frankly, we don't need the lines sort of dividing everything up anymore. And we have 1, 2, 3, 4. We have 5 lines. So we have achieved our goal of 5 lines in the draw. So let's go ahead and check this in. It's good to check things in often so that if you need to roll back, you don't have to throw everything away and start from the beginning or something. If you check in regularly, just roll back to the last time it worked. So that reminds me, let's go ahead and test this. We'll make sure that it worked. Now, the one thing I noticed, he doesn't have unit tests for this. And so the only way to test it is that you build it, and then you go and you refresh, and then you just kind of run through. And since that pretty much exercises everything that you'd want to do, moving through the air, moving through the flux, and dropping rocks and boxes and unlocking, then that makes sure that it still works as you expect it to. So it still works as I expect it to. So I'll just put in a message here. I extracted draw player and draw map from draw to satisfy 5 lines of code rule. I always forget to add it to my. So basically that's what he suggests we do. Boom, draw map, and that's what we end up with. Pretty nice. So, and then he goes through and he talks about the process that you follow if you're going to be extracting a method. You mark the lines to extract, put comments around them, create a new empty method, start at the grouping. And if you use an editor like VS Code is what I'm using here, Visual Studio Code, or IntelliJ, or a nice editor, then it will have a lot of these refactoring tools built in, which is really handy. But if you don't have those, he's talking about these are the specific steps that you would take to do that. And then he walks through the process of going through each of these steps in a simple example. So he does a nice job of explaining things in very explicit detail about why you would do things a certain way, why you would take the steps that you take to avoid getting confused. And one other nice thing he does is he has further reading and suggestions of how you can learn a little bit more about this. And he often refers to Martin Fowler's book, Refactoring, which is a really good book. This is the Java one. He just released an update to this last year, maybe the year before, that focuses on JavaScript, and it changes some of the refactoring, adds some new ones, takes some old ones out that are, I guess, more appropriate to JavaScript. But anyhow, it's an excellent book. I definitely recommend you get it. So now he introduces a new rule: either call or pass. And so a function should either call methods on an object or pass an object as an argument, but not both. And this is really, if you've read Uncle Bob's book, what's it called? Yeah, Clean Code. Show you that, Uncle Bob's Clean Code book. Then he talks about how the solid approach, one of the approaches, one of the techniques in solid is that the single responsibility principle. I guess that'd be the first one. And if you can't visualize what that is, that's this the same rule here: either call or pass. You're going to do not the single responsibility. No, it's the have a function do one thing. Yeah, I guess that's single responsibility. So basically, you're either going to call a function or you're going to pass parameters, but you're not going to do both. And he gives an example here, like you're going to return, if you're going to get the average of an array, you're going to sum the array and then you're going to get the length. So you're either going to call a function and pass the array, or you're going to call a function on the array. But you can't do both because you're kind of messing with different levels of abstraction. So it makes it easier to read if I'm going to say, I'm going to sum the array and I'm get the length of the array. This is kind of a trivial example, probably wouldn't confuse you as much, but when you have larger functions, then it does confuse you. So he says we're looking at this this draw function, and he points out that we've got this g, we get the g, and then we call a function on a g, and then we pass the g as a parameter. He says, well, shoot, this is mixing, this is breaking our rule of call or pass, do one or the other. So what he suggests we do is you extract this, and you basically you get the graphics, and then you pass it as a parameter. So we'll again go and we'll refactor this, we'll extract this to a function. We'll call this get graphic. And now we're even less than 5 lines, but also we've got this this function. Basically, we've cleaned up draw so that we're doing one thing with G. We're either retrieving it or we're passing it as a parameter. And here we're wait a second. Am I doing that wrong? Canvas G. So you got draw, G create draw map G, but G equals, and then we're calling on. Oh, right. So yeah. So we're doing one thing here. We're retrieving it. We're calling a function on it. Here we're retrieving it, and we're passing it as a parameter. And here it's passed as a parameter, and we're calling on it. So basically, it's just one thing, one way that we're using it. We're not using it in 2 different ways. See? So it's, and it just makes things a little bit easier to use. So he says, okay, we've finished draw. Let's keep practicing this. So let's go to the update method. Well, first, we've done this. Let's go ahead and make our comment here. We want to extract, get graphics from the draw function to satisfy rule, call or pass, but not both. Okay. Oh, I didn't even say, oh, I didn't even build it. Goodness gracious. I should know better than that. You got to go and you got to test that puppy. So I build it, come over here, and I test, make sure it still works. And it looks to me like it does indeed. Okay, good. So now he's saying you go to update, and we'll go ahead and break this up into different methods. So let's look for update. Oops, not you, here. Update, right here. So see how that's kind of, you got two different groups of code that lend themselves to being broken up. So what he suggests is if you're to quickly name something that you're breaking out. And I thought this was a pretty clever idea. So basically, we're going to want to extract this out into its own method. And says, okay, so what has it got? It's mainly got this input stuff that it's using here. So we can call this update inputs. So we'll try that. So we'll go and refactor that. We'll call this update inputs. Did I name that right? Did I do it the same way he did? Yeah. Oh, handle inputs. Sorry. Yeah. So, right, because it is not actually doing the updates. So here we can see, does this have a rename? Function? No, doesn't have a rename. That's a shame. Well, we can just undo it and redo it. Factor, extract it to go, we'll call it handle inputs. I want to name it the same thing he does in the book so that when he tells me to look for a function that I know where to look. Okay. And similarly here, you look at this, and this is dealing mainly with the map. So, and it's making changes to the map. So we will call this update map. Right? So let's go and make sure that I did that right. Yeah, handle inputs and update map. And that's exactly what he did. So now we've got this function. And it just has two lines, the update function. And we've broken out these two. So I'll go and rebuild it, make sure that we didn't break anything. Oops. There we go. Try it. Looks like it's still working. That's good to know. All right, and so I'll do the right thing. I'll stage it before I check it in. I'll say extract handle inputs and update map from update to satisfy rule. 5 lines of code. Check that in, and we are good. So let's go back to our book. So it says, okay, we want to refine this further. We're finished with update, so we can continue one of the functions we just introduced, update map. And he introduces a new rule, if only at the start. So if you've got, if you have an if statement, then it should be a check, sort of a, what you call it, checking the contract of the function. So basically, he says if you're going to check the contract of the function, you should do that at the very beginning. You shouldn't be doing something else. So for instance, he's got this example where you're reporting on the primes and you're counting through numbers and you're checking to see if it's prime, then we'll log the ones that are prime. So you're doing a loop and a check, so that's two different things. So we come back to our single responsibility principle. It needs to do one thing. So got this report primes, and then you break it up, the if statement, into its own separate function. So you've got a report primes and a report if prime. So you've got each function is doing just that one thing. So this exists to help prevent the smell of functions doing more than one thing. And I like how he really goes into detail about what each rule is intended for, what code smell it refers to, and then where you can learn more about it if you go to the Robert Martin's Clean Code book, and he's got the methods should do one thing in his book. And so he doesn't give a page number or anything, but I mean, I think that's a chapter in the book. Anyway, and then he talks about how to apply the rule. This is what the refactoring for that would look like. So again, we'll go into the middle of it and we'll extract out the if statement. So here's our if statement here, right? And we will extract that and see, what did he call that? He called that update tile. Oops. Come on. Okay. Extracted to update tile. Boom. And he has, this went and reversed our Y and X. Let's go and change those back to what makes sense for us. I know that they're reversed in how it's accessed in the map. That's just the way this works, but we think alphabetically. And so it just makes it easier to read if I type X, Y. So we go and rebuild it, make sure that we didn't break anything by doing that refactoring. The nice thing about the automated refactorings is they're really dependable, and you can be reasonably confident that an automated refactoring is going to do things in a safe way. So it works. We'll come over here, we'll stage it, and we extract update tile from update map to satisfy the rule. Oops. That rule is if only at the beginning. Begin. Thank you. All right. So we did the same thing he did there. And we can do the same thing in handle inputs. So handle inputs right here. So we've got an if statement here with all this stuff. And we can say, sorry, what does he call it? He calls it handle input singular. That makes sense. Handle input. Because that's inside of a loop. That makes sense. So extract. Sorry, we've got to go and build it. It's important to follow your discipline. Okay, we come back here. Make sure that we didn't break anything. And everything looks like it works. Excellent. So we extract handle input, handle inputs to satisfy rule if only at the beginning. Beginning. Oh well, that's the way it goes. All right. So now we've made it all the way through chapter 3, and he's taught us, gives a nice little review here. He's taught us the 5 lines rule. He's taught us the either call or pass rule and the if only at the start rule. Well, that would be easier to type than beginning. That's okay. And in each of these, what we've done is extract method. So really, we've only learned one refactoring, even though we've learned a couple of different code smells and how to handle them and rules to follow to correct those, I guess, to notice those code smells and to determine what refactoring to do. So now we start learning more complex things in chapter 4. Does anyone have any questions, concerns? You should be able to get in and make yourself audible if you want. We'll go ahead and continue. So in this, we've got a new rule: never use if with else and never use a switch. And so then we're going to start learning the refactoring of replace type code with classes, push code into classes. And then specialized method is another refactoring. Only inherit from interfaces. That's another rule. And then we're going to learn inline methods and try, delete, and then compile. So there's a whole bunch of different refactorings and a whole bunch of new rules that we're going to learn in this chapter. And it's a fairly long chapter, but it's, again, it's exceptionally well done. So let's go to our handle input. And there we are. Good, we're there already. And he says, okay, so we've got the 5 lines rule, so we can't leave it. It's more than 5 lines. And our new rule is never use if with else, unless we're checking against a data type that we don't control. Okay, so, and the reason why is because we want to use if to do a check. If we're doing an if and an else in the same code, then what we're doing is we're sort of locking the code in. We're forcing the code to make certain decisions that would probably be better made at the place where the data is defined. So, and it says, you never want a hard-coded decision. So what we want to do is basically pull that out into a class. So let's see here, mapping the user. And so this is something here, basically we can't determine what the key is going to look like. We can't determine what that's going to do. And so we don't really have control over the data types that are used in these, which is why we leave the if else statement here. But we do have control over the cases in this case. I can redefine what the input's going to do and how it's going to be used and everything. So he gives an example of how we want to do this. So you got an if and else, then you'll say, if the length is 0, then we say we're not, no empty arrays, otherwise we're going to do this. So here what we'll do is first we'll say we'll assert that it's not empty, and if it fails, then it's going to throw an error, right? So it'll never get to this next line, and then we'll just do whatever function we have. So he calls this this is the problem of early binding. You know, you don't want to, you want to bind the functionality, the behavior of a function as late as possible. Let that decision be as close to the metal as possible, close to the original data if possible. So, you know, ifs are control flow operations. That means they determine what code to run next. But we've got object-oriented, an object-oriented programming language, so it's got much more useful control flow operators, which are the objects themselves. The object knows what it needs to do. It shouldn't have to go and decide what it's going to, how it's going to handle various things that it does. It already knows because it's using only its own data and running its own function. So what he says is, you know, we've got our own enum at the top, right, left, up, and down. So let's go ahead and create an interface. So what we're basically going to do is create the it's the man, it's our, I'm just losing my mind here. There we go, design patterns. Yes. Man, how do you forget design patterns? So basically we're going to create a the strategy design pattern to go and handle all of this instead of having if statements sprinkled throughout the code. So basically, if you look here in the code, let's go ahead and go up to the top. You've got this input enum. So what he's saying is, let's go here and we will create an interface, which we'll call this input2 as a temporary name. And what we'll do is we'll have a method for each entry in the enum is up. And it will return a Boolean is down, is left, is right. Okay, all right. So, so now what we can do is go down here, and instead of using this input here, we can use an input 2. Okay. And then instead of saying current equals input left, we'll change that to be current dot is left. I'm sorry, what was is right? Right. And all right. So what we can do is basically we'll look for any case of input and see if we can replace it with input 2. So you've got inputs here. Inputs is an array, all right. got handle inputs, and it handles current. So current would need to be from inputs. So if we go here and we make inputs and input 2, then we come down here, aha, we've got this input dot left. So instead of having the enum, now we've got to create an object to put in there. Okay, so since we've created this interface, we'll create an object, and we'll call this object, oh, I don't know, let's call it up. Up, implement input 2, right? And so we'll have is up, and that will return true. And then is down. It's a function, so it has those parameter thingies. Return false. I have is left. That will return false. Now this seems like a tremendous amount of work, but you'll see how this cleans things up. And it's a simple way to do it. So we'll do that. We've got up, down, up, down, left, and right. Up, so down would be here. Left. I'm sorry. Did I just mess everything up? Golly. Okay, so now we go down to the bottom, and where we would have the enum, instead what we'll do is we'll say new left. New up. New right. New down. Okay, and you'll see we don't have any more red over here. Get this out of the way here. We don't have any more red over here. So that means that it must work. So basically what this does is it goes and pushes a direction onto whatever this inputs stack is. And then the current will handle input with this, with the inputs, and current will be what we pop off. So that will be an input to object. Then we'll handle that input object, input to object, by calling the method on that object. So it would be one of these, and it will take the appropriate action. Okay, so we're still got the else's in there, but you can see that if we build this, we'll come over here, and you see and it continues to work. So that's pretty clever. So now what do is we can take this function, this handle input, we come up here and we will add a handle input method here that returns a void. Okay. But if we go down, I'm sorry here, handle input takes a current, takes an input too. So, but we won't have to pass in an input too because that'll be me. So basically what I'll do is I will go in, I'll create a handle input, input method here. And I'll take the code that I had down there and I'll put it in here. Okay. And so it won't be current. Now it'll be this. Okay. And I will take this handle input method and I will put it in each one of these new classes. Okay. And so they will all handle it. And you see we've got no red over here. So if we build it, you'll see that it continues to work. So we go in. So I'm able to move left and right. So now all we've done is taken that if statement and moved it into all of these. Well, that's kind of crazy. Well, let's go ahead and let's simplify this. This dot is left. I know since I'm in the up class that this is false. And this dot is right. I know that's false as well. And this dot is down is false. This is true. We'll do the same thing here. This dot is left, well, this is down. So that's false. Is right is false. Is up is false. This is true. So there we go here. This is left. So this is true. This is, try that again. This is false. This is false. And this is false. You can see that this is kind of dimmed. So VS Code already knows that it's what's true and what's false and what will work. So this is left, so this is this is right. So this is false. This is true. It's false. Okay, so we know how that works. Well, since we've done that, if it's always false, then it's never going to be run. So let's only run what's true. So we can take that all out and then simplify. We'll just put it on one line here. So we'll only do the true part. Same thing here. And so now we don't have any if statements there. And you can go down here to handle input. And frankly, we don't even need to call this function. Well, I guess what we could do is do current dot handle input, right? So here, we'll just go make sure that this works. We've just taken all that logic and moved it up into the object, right? So let's run it, and sure enough, it works just like it did before. Isn't that amazing? So now we can look at this and we say, you know, this only does one thing, so I could just inline it. Inline just basically means instead of calling it as a function, I'm going to do the function right here. So say current dot handle input, and then I don't need that. You notice that we got no red, so it still compiles. So we built it, make sure we didn't break anything. And everything still seems to work. Looks very good. So now we can do a little bit of cleanup. We go up here, and the thing is that handle input, well, you know, we're not really handling any input. We're just handling things. So let's, we'll just rename handle input to handle. So that makes things easier there. And then you know, we come down here, we just do current.handle. And current, well, let's just call this, instead of current, let's call this, we'll call this input. And now that reads more sensibly. So we're going to, from inputs, we're going to pop an input, and then we're going to tell that input to handle itself. And then the handle will go and it will either move vertical or horizontal. So we've made it really simple. We've gone and moved the functionality, the decision to the type of object we have. And and oh, looks like I'm going to have to wrap things up early here today. I've got to take my daughter to work, but I hope you found this educational, and we will get back to doing this next week. And thanks, guys, and we will look forward to learning a little bit more about this next week. Thanks. Bye.